Section 3 is explaining rational roots. The factor theorem, if you have a polynomial p of x and it is divisible by x minus a, in the case that the remainder is 0, then x minus a is a solution or a factor to this polynomial equation. Since the remainder is equal to 0, that means p of a, when you put a in this equation, you will get 0. So p of a is equal to 0 means that x minus a is a factor or is a solution for this polynomial equation. And the converse is also true. So if he told you that for a polynomial p of x, x minus a is a factor, that means if you put a in the equation, you will get 0. These two facts, which is the same thing, he's calling it the factor theorem, which is if you're dividing by x minus a, you will put a in the polynomial, you will get 0. That means this is a factor. Or he's already tell you that this is a factor, so when you put a, you will get the 0. It's actually both are the same thing, and they are calling it the factor theorem. So here, for example, he's telling you show that 2x minus 3 is a factor of this equation. So you put x is equal to 3 over 2 in this. 3 over 2 means 1.5. So when x is equal to 1.5, you will get that this is equal to 0. Or by using the synthetic division, you will get that the remainder is 0. So you know that 2x minus 3 is a factor of this polynomial equation. And here, that means factor. So after using the synthetic equation, you know that it's 2x minus 3 times 6x squared minus 5x minus 4. And this itself, you can factorize it to this. So you know that this equation is this times this times this. So the roots of the polynomial, which is the factor or the solution. For example, here he's asking to show that 3 is a root of this. So when you substitute 3 here, you'll get the answer is equal to 0, means it's a root. Or using the synthetic division, you'll divide by 3. You will get that the remainder is equal to 0, means that 3 is a root of this polynomial equation. And he's asking here for the other roots. Then you have to put this equation, which is 6x squared minus 3x minus 45. And then he factorize it to x minus 3 and 2x plus 5. So already you have x is equal to 3 as a solution. So the other one will be minus 5 over 2 or minus 2.5. Here he's just adding that in this example, you have x is equal to 3 as a repeated root. So he said that 3 is a root of multiplicity 2. So if the root is repeated m times, we call it a root of multiplicity m. Means this root is a solution and it is multiplied many times in the solution. Learning point 2, he's trying to explain how to find the rational roots of a polynomial. A polynomial of the first degree means x plus 1, for example. You have only one root, which is x is equal to minus 1. If you have a polynomial of 2 degree, means x squared plus 3x plus something, then you factorize it and you will get 2 answers, 2 roots, or maybe the same root if it is repeated. Here he's explaining another fact to get the roots for the 3rd degree or 4th degree or 5th degree polynomials. So here he's explaining that if you have a polynomial equation, then the roots must have the form of s over t, where s is a factor of the constant term, which is the last number, and t is a factor of the coefficient of the highest degree. For example, you have a number x to the power of 5 plus something 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 plus the constant here. So this constant, it has a factor, let's say s, and this one has a factor, one of the factors is t. So he's saying that the roots, it must be from the form s over t. So the constant over the highest, the coefficient of the highest number, you will do the factors and you will take the factors of the constant. This divided by this, it will give you the options of the roots. Taban, he didn't say the proof of this, but it will be explained in the example. Let me explain in this example how you can get the roots of a 3rd or 4th degree polynomial. So here you have the constant as 6. You will take the factors of the 6. which is 1 times 6, or 2 times the 3. So you have 4 factors of the number 6. The coefficient of the highest factor of the highest variable, sorry, it's 2. So 2, what is the factors if 2 is 1 times 2? So your factors or your answers, your solutions of this is one of the set, this over this. So I'll try 1 over 1, which is 1, 1 over 2, 2 over 1, which is 2, 2 over 2, which is 1, 3 over 1, which is 3, 3 over 2, which is 1.5, 6 over 1, which is 6, and 6 over 2 is 3. It's already here. So you just cancel the duplicates. So you have 1 over 2, 1, 2, 3, 1.5, and 6. So this is your factors for this polynomial equation. It will be one of these two numbers. It will be, yani, if you have 3 answers, it will be from this. If you have 2 answers, it will be from this. So these are the possible list of the factors of this polynomial equation. Then, for example, here he said how to get this. So he takes, for example, he take طبعا positive or negative. يعني it could be 1 over 2 or minus 1 over 2, 1 or minus 1. So all of this, it's positive or negative. So how he knows? For example, he divides by, here he divides by minus 2. He get the remainder 0, so that means minus 2 is a factor. طبعا he has to try each one of them to know if it is a factor or not, or you have to just substitute 6 into this. If you get the answer 0, that means this is a factor. So let's explain example 4. Consider this polynomial. Okay, he wants to determine all of its roots. طبعا here you can expect that you will have 4 roots. So the factors of 1 is 1. The factors of 8 is 1, 2, 4, 8. So you have 1 over 2, 1 over 4, and 1 over 8. Plus and minus are the possible roots. You don't know which one. You will try to use the easiest way. You put the 1 here, so you will know if it's a factor or not. If this is equal to 0, so the 1 is one of the factors. So here he used 1 over 2. So he divided his polynomial equation divided by 1 over 2. He gets the remainder 0, so he is sure that this is one of the roots. And the remaining equation will be 8x cubed minus 12x squared plus 8x minus 2. So this is one of the factors, and this is the other factor of this equation. So طبعا here instead of x minus 1 over 2, he put it 2x minus 1. It's the same thing. So another possible root, he used it again 1 over 2. You can use that means this is a multiple root here. So he divided this cubic equation divided by 1 over 2, and the remainder is 0, means again 1 over 2 is another solution. So you have 2x minus 1 squared, and then here 2x squared minus 2x plus 1. Here you can get the roots easily because you know that equation b plus minus radical b squared minus c squared minus 4ab, I believe, over 2a. So using this equation you can get the solution. طبعا the solution here is irrational because you have here radical minus 4. So radical minus 4, you remove the radical minus 1 as I, and radical 4 is plus minus 2. So your solution is 1 over 2 and 1 over 2 minus 1 over 2i, and 1 over 2 plus 1 over 2i, and 1 over 2 and 1 over 2. So this is how the factors of the equation. And the roots of it is x is equal to 1 over 2, which is multiplicity 2, means it is repeated 2 times, and 2 irrational factors. I'm just going to explain example 5 in case it came in the exam. So he gives you have a 32 inch by 18 inch. This is 32 inch by 18 inch rectangular sheet of metal. You have a big sheet. An open top box is to be formed. You want to make a box out of this sheet, okay? So he told you that you need to fold it, and this is the height. This represents the height. When you cut it and then you fold it, you will have the box with open top. So the height is x and the length is 32 minus 2x because you're taking from here and from here, and the width is 18 minus 2x. So he's saying that x is equal to 3 inches is one possible solution. So this box have a volume of 936. What is the other possible values of x? And how much should I cut? So my height and the volume of the box becomes 936. So here you have the length, which is 32 minus 2x, and you have the width 18 minus 2x, and you have the height, which is x. You multiply all the three together, you get this quadratic equation. It's equal to 936. He wants the volume to be 936. So taking this to that side, you have your polynomial quadratic equation. He already told you that x is equal to 3 is one solution, so you need to get the other two solutions by dividing this over this. So you will divide by 3, and then you will get that the equation, the remainder 0, because 3 is one of the solutions. So you get x squared minus 22x plus 78. So now I need to get the roots of this equation, which is the possible values of x. So you can use the formula minus b plus minus radical and so on, or you can, here I don't know what he used, but he got that the roots is 4.44 or 17.56. Now 17.56 is rejected because if you put 18 minus 17.56 you will have point something, so it will be very small. Your volume will never equal to 936. So 4.44 is the other possible value for the height, or for x. Now I will solve the course practice 4.3, and I hope that the question makes more sense after solving it. Question 1. Which of the following is a possible root of this equation where m is a whole number? I can get the possible roots. The constant is 7, and the factors of 7 is 1 and 7. The coefficient of x to the power of 3, which is the highest one, is 1, and the factor of 1 is 1. So I have the possible roots is 1 over 1, which is 1, or 7 over 1, 7, plus minus. So it's 1, minus 1, 7, and minus 7. These are your possible 7 roots. طبعا these two are not one of the possible roots, so my possible one, he said select what is the possible. Okay, so he didn't say it's correct or wrong, but this is possible. So I have 1, minus 1, 7, and minus 7. These two are not from the possible ones. So you get the factors of the constant, and then you divide each one of them by the factors of the coefficient of the highest exponent. Question 2. Given that p of x is equal to 38x to the power of 4 plus ax cubed plus bx squared plus cx plus 12. If k is an odd integer greater than 1 and 2 over k is a possible root, then what must be the value of k? Let me get all the possible roots. I have the constant 12, and this is 38. So 38 is, the factors of 38 is 1 times 38 and 2 times 19. These are the factors of 38. The factors of 12 is 1 times 12, or 2 times 6, or 3 times 4. This is the factors. So we have 1 over 1, or 2 over 1, or 3 over 1, and so on. So he said 2 over k. He already gave you 2 over k. So I know that I'm not taking all of this, I'm just taking the 2. So I have 2 over 1, which is 2, or 2 over 2, which is 1, or 2 over 19, or 2 over 38, which is, after simplification, it will be 1 over 19. So the possible solutions when taking the 2 only is 1, 2, 1 over 19, and 2 over 19. So he wants, k is an odd number. طبعا this is not 2 over something, so this is 2 over 19, and k is an odd number, so k is equal to 19. Here this is 2 over 1, but 1 he already told you here it is greater than 1, so you cannot take the 1. So you only have to take the 19. 19 is the only option here. Question 3, consider this polynomial. Select the correct option from each drop-down menu. According to the factor theorem, he gave here g of 4, g of 3, g of 0, and g of type. I need to know which are the possible factors. Again, the factors of 12 is 1, 2, 3, 4, 6, and 12. And here the number in front of x to the power of 3 is 1. So I have all of these as a possible roots, plus, minus. Here he gives the option, I think, 0, and 3, and 4, and 1. So if you put here, you try all of them here. If you try here 0, the answer will equal to 12, so it's not a factor, or it's not a root. It should equal to 0. So the only one that will make this equal to 0 is 4. So 4 is your root. So according to the factor theorem, since g of 4 is equal to 0, then x minus 4 is a factor of this equation. I already know that x minus 4 is one of your factors. So one way is to try all the numbers and see what will equal to 0, or to just make the scientific division, which is, I think, easier. So I have here x cubed, so 1 minus 2 minus 11 and 12 divided by 4, because x is equal to 4 is one of your roots. So here you'll put the 1. 1 times 4 is 4. 4 minus 2 is 2. 2 times 4, 8. 8 minus 11 is equal to minus 3. Times 4 is minus 12. This will equal to 0. If you didn't get this 0, you know that something is wrong, because you know that this is already a factor, so the remainder should be 0. So your equation is x squared plus 2x minus 3, and your other factor is x minus 4. This one I can factorize easily. It is x, and 3 times 1. This is positive, so this is positive, this is negative, and this is x minus 4. So here your three factors in part B is x minus 4, which you already know, and then x plus 3 and x minus 1. He wrote for you x minus 1, and you know already x minus 4, so x plus 3. Question 4, factor this polynomial, given that 25 is one of its roots. So I already give you one of the roots, so I will use the synthetic division. This is 1 minus 25, 4 minus 100. I know is x is 25, x is equal to 25 is one of the roots, so I'll put here 1. 1 times 25 is 25, plus minus 25 is 0. 0 times 25, 0, plus 4, 4. 4 times 25 is 100, minus 100, 0. And I know that the remainder should equal to 0, because this is one of the factors. So you have x minus 25 as one of the roots, because he already gave it to you. And you have here x squared. X is 0, so plus 4. This is the factors of this equation. So you need to get the other two. You need to get it something times some. Here he put I, which I know, because x squared plus 4, your roots is x squared is equal to minus 4. So x is equal to radical minus 4, which is equal to radical 4 and radical minus 1. This is I, and this is plus minus 2. So your roots are x minus 25, x plus 2i, and x minus 2i. So here x minus 25, you already know this one. Here x plus 2, and he put the I, and minus 2, and he put the I. And this is irrational roots. Question 5, consider this polynomial. Given that k over 7 is a root, what could be the value of k? I have the constant is minus 3, or I'll put it at 3, because anyway you're taking plus minus, and here it is 7. Okay, the factors of 3 is 1 and 3. The factors of 7 is 1 and 7. So your possible roots is 1 over 1, 1 over 7, and 3 over 1, and 3 over 7. So you have 1 over 7, and 3 over 7, and 1 and 3. Here he said k over 7. So you have 1 over 7 or 3 over 7. What is the value of k? He said list all the possible rational roots and test the numbers. طبعا here you need to test the number because you don't know if you'll take 1 over 7 or 3 over 7. So I will test here 1 over 7. So 7 times 1 over 7 to the power of 3 minus 17 times 1 over 7 square plus 13 over 7 minus 3. طبعا here you got an answer. You didn't get 0, so that means 1 over 7 is not a root. So I already know that 3 over 7 is the root that he's looking for, but again let me put it on the calculator to reconfirm. So 7 times 3 over 7 cubed minus 17 times 3 over 7 squared plus 13 times 3 over 7 minus 3, you get the answer is equal to 0. So you know that 3 over 7 is the root, so the number he wants here, k, is equal to 3. Part B, he wants the other factor type. I already know that 3 over 7 is one of the factors. And your equation is 7x cubed minus 17, 13, and minus 3. 7 times 3 over 7 is 3. 3 minus 17 is equal to minus 14. Times 3 over 7 is minus 6 plus 13 is equal to 7 times 3 over 7 is 3 minus 3 is 0, and you should get a remainder 0, otherwise your answer is wrong because this is a factor. So your equation is 7x squared minus 14x plus 7, and this is the other factor. So here he put it طبعا here this is something times something, so that means he already factorized it. To factorize completely, so this one I can factorize again. I can take 7 outside. X squared minus 2x plus 1, which is x minus 1 and x minus 1. So this is, yeah, x minus 1 squared, and you already know 7 is here, and you have x minus 3 over 7. So multiplying this, you have 7 x minus 3, one of the factors, and x minus 1 squared is another factor. So here he wants you to write it. So x minus 1 squared here, because I got it 2 times 7x minus 3. And then what is the root of it? طبعا you know x is equal to 1 and x is equal to 3 over 7. These two are only the roots, and one is repeated or multiplying root. Last question, what is the value of m if x plus 2 is a factor? So if you put x is equal to minus 2 in this equation, you get 0. X is a factor means your remainder is 0. So I'm using the remainder theorem. So if I put x is equal to minus 2, so minus 2 to the power of 4 minus 2 to the power of 2 plus 3 times minus 2, 3 times minus 2m plus 64 is equal to 0. The remainder is 0 when you put x is equal to minus 2, because x plus 2 is a factor. I'm using the remainder theorem. So minus 2 to the power of 4 is equal to 16. Minus 2 to the power of 2 is 4 times minus 2, so minus 8. This will be minus 6m plus 64 is equal to 0. Let me simplify. 64 minus 8 plus 16. It goes to the other side, minus 72 divided by 6. So m is equal to 12.